All right. Hey, everybody. We are in Unit 5, Unit 9, Lesson 5 of the Tennessee Revealed Geometry, getting into trigonometry, which is sine, cosine, tangent. Of course, there are 3 others, but in geometry, we only talk about the first, sine, cosine, tangent, and its inverse, sine, cosine, and tangent. All right. So we are on page 533 of your consumable workbook, everybody. And let's just get into it. You're going to need a calculator, and you're going to need a calculator that is in degrees. So I don't know what kind of calculator you guys have, but I've got a regular old scientific calculator. It is not a graphing calculator, and that is perfect. It's going to need to have sine, cosine, and tangent as well as the inverse. So it doesn't really matter if you have a graphing calculator or just a regular old scientific calculator. Okay, so the first thing we need to talk about is how to know what these ratios are, because we're talking about ratios of two sides of a right triangle. It can be a combo of the hypotenuse and one of the legs, or it can be a combo of the two legs and have nothing to do with the hypotenuse. It could be finding an angle that's not a 90-degree angle, one of the acute angles of a right triangle. And then trig you can use for triangles that are not right triangles, and that's usually the law of sines and law of cosines, and we're definitely going to get into that later. All right, sine is your opposite side of the angle divided by your hypotenuse, which is the side across from the 90-degree angle. Cosine is the adjacent side to the angle divided by the hypotenuse, and tangent is your opposite side of the angle divided by the adjacent side of the angle. So it kind of depends on which angle you're talking about, but you're never going to be talking about the 90-degree angle. It's always going to be one of the acute angles that you're going to refer to. Now, a way to remember this, you can say OH is Oscar had, AH is a heap, and tangent is O over A is of apples. So Oscar had a heap of apples. And it doesn't really matter what kind of calculator you're looking at or using, they always go in the same order: sine, cosine, tangent. So Oscar had a heap of apples, or whatever you want to use to remember OH, AH, and OA. Several years now, I've been teaching for, almost 3 decades. So I will use something that they're definitely going to remember, and that is old hippies are high on acid. So if your students take offense at this and they want to use Oscar had a heap of apples, that's perfectly fine. Hang on a second, guys. I got somebody walking into my room. All right, I'm back. All right, so let's just get into it. I think most of you are visual people that I've learned over the years, so that's going to help. All right, example number 1. So I'm turning the page. Looks like I'm on page 534 of your geometry book. All right, it says, find sine of j, cosine j, tangent of j, sine of k, cosine k, tangent of k. Express each ratio as a fraction as a decimal to the nearest hundredth. Okay, sin is not sin. So if you're a student, please don't call it sin. It's like scraping your nails on a chalkboard. If any of you guys have chalkboards anymore, it's sine, S-I-N-E. Sin is just an abbreviation. Same thing for cosine and tangent. All right, so the first thing you do is you look at what letter they're talking about. That's referring to the theta, which is the angle, the acute angle. So J is our theta. There's our angle right there, J. Sine is the opposite side of J, which is the one all the way across the other side. That is why they have 5 on top, divided by the hypotenuse, and that is the side that's across from the 90 degree. That's your longest, the slanted side, and it's going to be 13. So we're going to take our calculator and do 5 divided by 13, and they want it rounded to the nearest hundredth, which is 2 numbers after the decimal. Now, really, you're looking at 0.384, but that 4 does not make the 8 change, so it's going to be 0.38. Cosine of j, there's j. cosine is adjacent side to J over the hypotenuse. Well, if this is our angle J, our theta, 12 is the one that's next to it. That's going to be 12 on top, hypotenuse still on the bottom. So 12 divided by 13, rounded to the nearest hundredth, is 0.92. The 3 does not make the 2 change. All right, tangent of J. Again, here's our theta J. Tangent is opposite divided by the adjacent. So 5 goes over 12, and 5 divided by 12 is 0.4. Now it's going to 1 has a 6 behind it. So that 6 makes that 1 round to a 2. All right. Now I'm going to show you guys how to do sine of k, cosine of k, tangent of k, and I'm going to show you a trick after I do the real way to do it, so you can remember pretty quickly. All right, sine of k. So this time our theta is k. Sine is opposite of k, that's 12, over the hypotenuse. And the hypotenuse does not change, but the opposite side to k is a 12, whereas the opposite side to j was a 5. So it's going to be 12 over 5. Divide those, 0.92. All right, cosine of k. Again, k is our theta. Cosine is adjacent over the hypotenuse, so 5 over 12. Divide those, and 0.416 is going to round to 0.42. All right. 5 over 13. All right, and tangent of k. That's your opposite over your adjacent. So it's going to be 12 over 5. All right, and 12 divided by 5 is 2.4. And it doesn't change, so it's be 12.4. All right, so there we go. Expression fraction decimal nearest hundredth. There we go. Okay, so you'll notice that some of them are the same. And I think I messed up. Yeah, I was about to say, something's not right. And I hit the wrong button on this one. So let me go back to this. 5 divided by 13 should be 0.38. All right, so yeah, that's an oops on my part. And here's how I knew it was wrong. The sine of j and the cosine of k should be the same thing. And cosine of j and the sine of k should be the same thing. So I knew that I did something wrong because cosine of k and sine of j should have come out to be the same. So I knew I did something wrong somewhere along the way, so I had to figure out which one I did wrong. All right, there we go. All right, so is that all I got to do for example 1? Yeah, it is. All right, let's go on down to example number 2. Okay, so we're going to use special right triangles to find trig ratios. Okay. So the special right triangles is on a 30, 60, 90 is the short side is your x, the hypotenuse is twice that x, and the long side is x with the square root of 3. Now we did that back in a previous lesson, so it looks like here it is again. All right, so it says, write the correct side lengths for each leg of the right triangle with x being the length of the shorter leg. Well, your short leg is always across from the 30. The opposite to the 30 is your short side. That's going to be our x. Hypotenuse is always twice the measure of that, so it's going to be 2x. And the longer side, the one that's across from the 60-degree angle, is going to be x with the square root of 3. Now, I'm wondering why they don't let me do the square root of 3. Okay. So it's the same thing as x to the 1/3, but it should be x with the square root of 3. And it's not letting me put in my square root. So I guess you're going to have to know it's the square root of 3. All right, so here we go. Sine of 60. Remember, sine is your opposite of your hypotenuse. That's your Oscar had, your old hippies. Either way you look at the theta being 60. Opposite to that is the x square root of 3, and that's going to be on top. And the sine is hypotenuse on the bottom, and that's 2x on the bottom. So that's why they have x squared root of 3 over 2x. And of course, the x's actually cancel out, because if you have an x on the top and one on the bottom, they cancel each other. So really, you're looking at the square root of 3 over 2. Now, ACT likes to leave that square root of 3 over 2. So I'm kind of surprised it's making us use a calculator. So everybody grab a calculator, put in square root of 3 divided by 2. And you're going to look at a decimal of 0.866. And since the 6 makes the 6 round up, it's going to be 0.87. But listen, ACT likes the square root of 3 over 2, so keep it that way. Square root of 3 over 2. They don't like decimals. All right, looks like I'm done with example number 2. All right, going on to example number 3. Okay, you got a word problem here. All right, estimate measures using trigonometry. Okay, Matthias builds a ramp so his sister can access a back door of their house. Looks like she's in a wheelchair. The 12-foot ramp to the house slopes upward from the ground at 4 degrees. Okay, this is your angle. We're talking about angle A. All right, what's the horizontal distance? That would be the x. That's horizontal. Y is vertical. So they're looking for the horizontal distance, x, between the foot of the ramp and the house. And then what is the height of the ramp? So they want the y as well. Find the horizontal distance. Okay. Well, it looks like our ramp is 12 feet. And that is your hypotenuse, because it is the side across from the 90-degree angle. Kind of a skinny triangle, so it might be hard to see it, but that is your hypotenuse, because it's the longest slanted side. All righty, so first thing we're going to do is find our adjacent side to the 4. So your angle A, the theta is 4 degrees, which means we're going to use the adjacent side and the hypotenuse to find the horizontal distance. This is a cosine, everybody, A over H. So you're going to replace your angle A, your theta, with the 4 degrees. Since the adjacent side is x, you're going to replace the adjacent with the x. And since the hypotenuse is 12, you replace the hypotenuse as 12. All right, so now we've got an equation that you're going to solve. The opposite of dividing by 12 is to multiply the other side by 12. So we're going to multiply 12 times the cosine of 4. So everybody grab your calculator, put in 12. Hit cosine. And in parentheses, put 4 degrees, because that's your theta. Hit enter. And if your calculator is in degrees, which it needs to be to solve this correctly, you're going to get 11 point, and we're rounding this to the nearest hundredth, so to be 97, because 970, the 0 does not change the 7. So it looks like the horizontal length is just under 12 feet, 11.97 feet. All right. Got to find the height. Okay. So the height, according to this angle over here, is the opposite side of the angle theta, angle A. Opposite, and the hypotenuse is using the sine. So that's why they have sine here. All right, so sine of 4 degrees, because your theta is the angled degree, so it'd be 4. Opposite would be the y. And we're going to divide that by the hypotenuse. And remember, the hypotenuse was the 12. It's the slanted long side. Okay, opposite of dividing by 12 is multiply by 12. So everybody grab your calculator, put in 12 sine, and in the parenthesis, put in 4 for your degree theta. And you're going to end up with 0.837, but the 7 makes the 3 go to a 4. All right, so it's going to be approximately 0.84. All right. Looks like we're done with example number 3. All right, so let's see what's coming up next. All right, inverse. Okay, inverse is what you use when you're looking for the measure of an angle. All right, so if you're looking for the theta, like they do not give you the angle measure of one of the acute angles of the right triangle, then you're going to have to use inverse. Still, Oscar had a heap of apples. That does not change. Sine is still your opposite over your hypotenuse. Cosine is still your adjacent over the hypotenuse. And tangent is still your opposite over your adjacent. But it depends on your angle. You might have to do inverse in order to solve this instead. All right, so here we go. Example number 4 says use calculator to find the measure of angle A. So angle A is your theta. And you'll notice we do not have an angle measure. There's nothing there saying degrees. So we are solving for the angle. So it depends on what sides you've been given as to which formula you use. Now, we have a right triangle, and we have one of the legs, and we have the side that's opposite to the 90, which is our hypotenuse. So I know it's going to be either sine or cosine because those both have the hypotenuse in the formula. But since I'm looking at angle A and I have the side that is adjacent to A, not the opposite to A, I'm going to be using cosine on this problem because cosine deals with the adjacent to the angle and the hypotenuse. Okay, so we are looking for the theta. A is going to stay A because I do not have a number to replace it with. The adjacent side is the 3. So 3 goes on top. The hypotenuse, the 15. The 15 goes on the bottom. Now, because we're looking for an angle, we do what's called an inverse, that little -1. So everybody grab your calculator and look at your sine, cosine, tangent. Somewhere close to it, if you're looking at a graphing calculator, it's probably pulling up in your menu a little chart, and you'll just pick the one that has the little -1 power, whichever one you're using. But if you're using just a regular scientific calculator, look at the sine button, and the sign to the -1 may be in a different color. Maybe it's yellow or green or blue. On mine, it's a green sign to the -1, which means I have to hit my green button, then hit my sine button to pull up inverse sine, or green button, then cosine button to pull up inverse cosine. You might have to hit a yellow button. Who knows? Depends on what kind of calculator you've got. But I'm going to have to hit my green button, which is my second button, and then cosine to pull up that cosine to the -1. And then I'm just going to put in 3 divided by 15. And I'm going to hit enter. And you should, if you're in degrees, be looking at 78.436, yada, yada, yada. They want us to round to the nearest 10th, which is one number after the decimal. And since it's a 4, 6, the 6 makes the 4 jump to a 5. So it's going to be 78.5 degrees. 78.5 degrees. Oh, looks like I forgot something. So it's going to be 3 divided by 15 is our ratio. All right, so we got 78.5 degrees. And that's the answer for example number 4 on page 535 of your workbook. All right, so turn to the next page. We got our check. We want to find the measure of angle Z to the nearest 10th. All right, so Z is our theta. All right, so let's look at what sides we have. We have a leg and we have a hypotenuse. So I know it's going to be either sine or it's going to be cosine because I have a hypotenuse, which is 14, and sine and cosine both have a hypotenuse in it. Now, according to angle Z, I have the adjacent side to Z. So if you're wondering which one I'm going to use, it's cosine because Z has the adjacent side 10 and the hypotenuse 14. So we're going to do an inverse cosine. But let me set this problem up first. All right, so it's going to be cosine Z equals adjacent divided by the hypotenuse. That's how you set this up. Cosine Z, adjacent over hypotenuse. And because I need to find the angle, I am going to do what's called inverse. I'm going to do cosine to the -1 of 10 divided by 14. And so everybody grab your calculator and make sure you have the -1 power on your cosine because you're looking for the theta. So you might have to hit your second button or your shift key before you hit cosine. And you're going to put in 10 divided by 14. And then hit enter. So you should be looking at z is to the nearest 10th, 44.4 degrees. All right, 44.4 degrees. All right, that's angle Z. All right, do I have to find anything else? No. All right, so it looks like I'm good on that check. All right, so now we're going to probably solve, yes, an entire triangle. All right, let me turn to the next page, and you're just going to move down to the bottom of page 536. All right, so it says to solve this triangle. Now, what that means is I got to find everything that's missing. I got to find angle R. I've got to find angle T. And I have to find the third side, R to S. I have two sides, 6, and I have the hypotenuse, which is 9. So it doesn't matter, I guess, what order you do these in, but to find that third side, it's going to be a Pythagorean theorem because that's the shortest way to do it. A squared plus B squared equals C squared, C being the hypotenuse. So I have a feeling I'm going to end up doing that. Yep, there it is right there, the Pythagorean theorem. And looks like I'm going to do an inverse to find either angle R or angle T. But once I do that, I can do 3 angles of a triangle. I love it. Yeah, that's what they're doing. Equals 180. Or 2 angles of a right triangle equal 90. So I like that they're doing the shortcuts here. That makes your life easier than having to do 3 different trig problems. Okay, let's do this. All right. So they are choosing to do angle R first. So we're going to do angle R. That's your theta. All right, so you got to know what sides you have. Well, we have one leg and we have the hypotenuse. So we got to decide which leg we have according to angle R. It's the one that's all the way on the opposite side of your triangle, which means you have your opposite side. And of course, you have your hypotenuse because it's the one across from 90. So this is a sign problem because you have Oscar had, you have your old hippies. So it's going to be 6 over 9. And because we are looking for a theta, which is angle R, you're going to do an inverse. So everybody grab your calculator. I'm going to do, use the inverse sine function, use the calculator. So we're going to do inverse sine of 6 divided by 9. And it looks like you're looking at 41.8103149. But of course, they want us to round that, I'm sure, to the nearest 10th. So that's going to be 41.8 degrees. So we got 41.8 degrees for angle R. All right, now the shortcut is 3 angles of a triangle add up to be 180. So you can take 180 and subtract angle R and angle S. Or you can realize that angle R and T add up to be 90 because 90 and 90 equal 180 and do it that way. So you're taking 90 and you're going to subtract 41.8. All right, so 41.8. All right, add the angle T equals 90, subtract 41.8 from the 90, and you're going to end up with 48.2. 48.2, that's the measure of angle T. And now listen, if you want to check your answer, 41.8 plus 48.2 plus 90 should add up to be 180. All right, so we got the measure. Okay, so yeah, 48.2. All right, last but not least, the third side. It's easier to do a Pythagorean theorem, so it's going to be a squared plus b squared equals c squared. That is your hypotenuse. So a squared plus b squared equals c squared, and that's going to be 9 squared minus 6 squared. So everybody grab your calculator, put 9 squared minus 6 squared, and that gives you 45. And the opposite of squaring is to square root. So we're going to square root of 45. Now, ACT likes to leave that 3 square root of 5. So please, teachers, teach your students how to do that, how to break down a radical. So it needs to be 3 square root of 5. because 9 times 5 is 45, and the square root of 9 is a 3. So it needs to be 3 square root of 5. But they're wanting it as a decimal round to the 10th, which is fine. So 6.7082, yada, 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 is going to round to 6.7. All right, there's your length from R to S. That is your third side of your right triangle. All right, got a check here. All right, so angle C is going to be easy. We're going to take 90 and subtract 62. So 90 minus 62 is 28 degrees. All right, AB is the side adjacent to the 62. And we have the hypotenuse. That means we're using cosine. Cosine 62. Let me write this down for my visual people. 62 is our theta, is your adjacent AB over your hypotenuse 10. So AB divided, sorry about that, by 10. The opposite of dividing by 10 is to multiply by 10. Goodness, I can't type today for some reason. And that's going to equal a, I really can't type today, equals AB. So everybody grab your calculator, put in 10, cosine. Now regular cosine this time, because remember we have our theta. 62 in the parentheses. And we're going to look at, rounded to the nearest 10th, 4.7, because 6, 9 rounds to a 7, and that's going to be the length of A. We're going to put in 4.7. AB, 4.7. All right, now we're finding BC. Well, BC is the opposite side to the theta 62. So you'll be looking at opposite and still using your hypotenuse. Now, by the way, you can use 4.7 if you want to. You'd be looking at a tangent problem, but I like to use what is visually there. 62 is our theta, CB is your opposite side, and 10 is your hypotenuse. So this is a sine problem. Opposite, hypotenuse. So we're going to do sine 62, because that is our theta. Opposite, which is CB, divided by our hypotenuse 10. The opposite of dividing by 10 is to multiply by 10. And that's going to give us CB. So grab your calculator, put 10, sine 62 in the parentheses, and round it to 8.8. That's going to be CB, 8.8. Okay, if you need an extra example, go online. If you guys have any questions, ask me. Ask your teacher. All right, you guys have a great day.